which was about the periodic table. So in the first question, 3 statements about the element carbon, nitrogen, and sulfur. So carbon is actually group 4 element, nitrogen is group 5, and sulfur is group 6. Carbon atomic number is 6, nitrogen atomic number 7, and sulfur is 16. So they are in a group next to each other in the periodic table. We have to check which statements are correct. So statement 1 is correct because one is in group 4, another one is in group 5, and the third one is in group 6. So statement one is correct. Then their neutron to proton ratio are all 2:1, like number of the neutron are twice as compared to number of proton. That is not correct. Why it is not correct? Like example, when I write for a carbon is 6 and 12. So carbon contains 6 proton and it contains 6 neutron. So when I take a ratio proton to neutron to proton ratio, like 6 neutron divided by 6 proton, the simplest ratio is actually 1:1. Same thing for nitrogen. Nitrogen is 7 and 14, so it will contain 7 neutrons because the difference, and it contains 7 protons. So ratio is again 1:1. And for sulfur, that is also 16 and 32. So it contains 16. When we subtract 32 minus 16, so 16 neutrons are there and it has 16 protons. So what is the simplest ratio between neutron to proton? That is 1:1. So they all have the ratio neutron to proton ratio is 1:1. Like if how many neutrons are there, same number of proton. But in option, so that is not the right answer. Like 2 is not correct statement. They each form an acidic oxide. Acidic oxides are non-metal oxide. So they all are non-metal. Carbon is a non-metal, nitrogen is a non-metal, sulfur is also a non-metal. So when carbon dioxide is there, oxides of nitrogen such as nitrogen mono or dioxide, or oxide of sulfur such as sulfur dioxide or trioxide, what is the characteristic? They all are acidic because non-metal oxides are acidic oxides. So statement 3 is also correct. So statement 1 is correct and 3 is correct. That's why the right option is C. Then in question 2, what is a property of halogen? Their atom decrease in size down the group. That is wrong because this does not happen for any group. Like we have fluorine, which will have 2 shells. We have chlorine, which will have 3 shells. We have bromine, which will have 4 shells. So even this is not a property for any group. Down the group, the size always increases. Size does not decrease. So that's why this is not the right statement. Their melting points increases as we go down. That is correct. Why it is correct? Because fluorine is gas, chlorine is gas, bromine is liquid, and iodine is solid. So like fluorine existing as a gas, and they all exist as a diatomic molecule. Chlorine exists as a gas, bromine exists as a volatile liquid with a low boiling point, and iodine exists as a black or a purple solid. So it is obvious that iodine is solid. So what happened to melting point as we go down the group? The melting point will increase. That's why B is the right answer for this. In question 3, part of a periodic table shows the position of 4 elements. These are not elements, actual symbols. Which element has the highest melting point and variable oxidation state? So basically, high melting point and variable oxidation state, these are the characteristic of the transition element. And where in the periodic table we can find the transition element? That is between group 2 and group 3. This region we can find transition element. So the option C is the right answer. Group 1 and group 2, these are, one is alkali metal, alkaline earth metal, and the D is actually a non-metal. So these properties, high melting point and variable oxidation state, are the properties of a transition metal which we can find between group 2 and group 3. In question 4, some properties which make element different from each other are listed. Like metallic character is there. This can be used to distinguish number of electrons, number of protons, total number of electron in an atom. Which two properties increases across the period? Like example, in a periodic table, as we move from left to right, here in the previous question, we have a periodic table. So if we move from left to right, the question is which property is increasing? Metallic character. So metallic character, how you can identify whether a metallic character is increasing or decreasing? So you can identify the nature of the element. On the left hand side of the periodic table, you will find metals. On the right hand side of a periodic table, you will find non-metals. So metals are on the left hand side, non-metals are on the right hand side. So it means as we move across the period, the metallic character decreases. It does not increase, it decreases. So the question is which two properties increases? So the first property is not the right answer. So one cannot be. Then number of electron shells. Look, number of electron shells across the period remains same. Why across the period remains same? Because period actually refers to number of the shell. Like this is the first period. So it means these elements will have only one shell. This is a second period. So elements which are there, they all will have two shells. So if I move across the period, when I move from left to right across the period, what will happen to the number of the shells? It remains same. It does not change because the period number represents the number of the shells. And as we say, element belongs to the same period, it means they will have the same number of shells. So across the period, the shell does not change. So number of electron shell of an atom does not change. So one cannot be an answer, two cannot be an answer. So any option which include 1 and 2 cannot be an answer. So it means this cannot be an answer, this cannot be an answer, this cannot be an answer. So we are left with D only. And we can check number of the proton and total number of electrons. If number of proton increase, total number of electron also increase. Like example here, this is lithium, so it is having 3 proton, then beryllium 4 proton, then boron 5 proton, carbon 6 proton, nitrogen 7 proton, oxygen 8 proton, fluorine 9 proton, and neon 10 proton. So as we move across the period, what we observe, the proton number increases. And what about the number of electrons? This will have 3 electrons, this will have 4 electrons, this will have 5 electrons, 6 electrons, 7 electrons, 8, 9, and 10. Because these all are neutral atoms, so they should have equal number of proton and electron. So electron number is also increasing. So that's why option D, which state that statement 3 and 4 are the correct statements, which increases as we move across the period. So in question 5, which equation shows a reaction that will occur at a room temperature? Always remember, the more reactive halogen displaces the less reactive halogen from its compound. So fluorine, chlorine, bromine, and iodine. Fluorine is the most reactive and iodine is the least reactive. So element, if it is above than the other one, it can displace. So when we check bromine with chlorine, bromine is below chlorine. So this bromine cannot displace this chlorine. There will be no reaction. So this cannot be an answer. Bromine with iodine. So we have bromine. Bromine is more reactive. So if bromine is more reactive, what will happen? It will displace this iodine from the compound. As a result, when bromine will displace iodine from the compound, there will be a reaction between them. So B is the right answer. But iodine with chlorine, iodine is less reactive than chlorine. So iodine cannot knock out this chlorine from its compound, so there will be no reaction. And iodine with bromine, iodine again, it is less reactive, so it cannot knock out the bromine from its compound, so there will be no reaction. So always remember, the more reactive halogen element displaces the less reactive halogen element from its compound. So the only thing, bromine is more reactive than iodine, so it can displace this iodine and this reaction will occur. The diagram shows part of a periodic table. Which element has a highest proton number and which element has a larger number of valence electron? Valence electron means number of electron in the last shell. So highest proton number, that is the atomic number. So you will use a periodic table. Lithium is 3. Atomic number of lithium is 3. Chlorine is 17 and calcium is 20. So the highest number of the proton, that is calcium. Then larger number of valence electron, number of electron in the last shell. So basically using a group number, you can identify the number of electron in the last shell. Lithium belongs to group 1. So this lithium will have 1 electron in the last shell. We are only talking about the valence shell, not the total number of electrons. Calcium belongs to group 2. So the last shell calcium will have 2 electrons. And chlorine belongs to group 7. So the last shell, it will have 7 electrons. And the question is, which atom is having the highest number of valence electrons? So that should be chlorine. So highest number of proton is calcium and highest number of valence electron is chlorine. So that's why B is the right answer for this. Question 7, a lump of an element can be cut by a knife. So you have to identify the element from its characteristic. Which element can be cut by a knife? That is group 1 element. Group 1 element are so soft that by using a knife, we can cut them. During its reaction with water, it floats and melts. What is X? So calcium is group 2, copper is a transition element, magnesium is group 2 and potassium is group 1. So cut by a knife, this is a characteristic of a group 1 element. So the only option we have group 1 element, that is potassium. And they have low density and they're highly reactive. That's why we store them under oil. In question 8, which statement about the properties of some elements is correct? All the noble gases are unreactive due to have 8 electrons in the outer shell. Look, this statement, only because of helium, it is not valid. Helium, what are the noble gases? We have helium, neon, argon, xenon, krypton. So these all are noble gases. But for helium, it is having only 1 shell and that is having 2 electrons. So 1 shell, the first is there and that is having 2 electrons. So because the shells are complete, that's why they are unreactive. Rest, all of them, they will have in the last shell, they will have 8 electrons, like neon will have 8 electrons in the last shell. Argon will have 8 electrons, but helium does not have 8 electrons. Helium is having only 2 electrons and that is in the first shell, which is complete. So that's why statement A is incorrect. Group 7 element acetylene, A2 is expected to be solid at room temperature. That's true. When we compare the state, fluorine is gas, chlorine is gas, bromine is liquid, iodine is solid, and acetylene is expected to be solid as well. Because like gas, liquid, solid. So what should be the state of acetylene? It should be solid. Then the reactivity of elements in both group 1 and group 7 increases. That is wrong. For group 1, as we go down the group, the reactivity increases. They become more reactive. But for group 7, which are non-metals, fluorine, chlorine, bromine, and iodine, as we go down the group, the reactivity decreases, they become less reactive. And so this is not the right statement. Then aqueous chlorine is added to potassium bromide, there is no change. That is wrong. Like if we add chlorine to potassium bromide, because chlorine is more reactive than bromine, so chlorine can knock out this bromine or displace the bromine, and it will form potassium chloride plus bromine molecule. So there will be a reaction here. They're saying no change or no reaction. So that's why this statement is incorrect as well. Element X and Y combine to form ionic compound. So means ionic compound means either one should be metal and another one is non-metal, because ionic compound can only be formed when metal combined with a non-metal. Atom of X has more proton than atom of Y, but that does not give any idea about whether they are metal or a non-metal, because they can have more proton, more electrons, but atom Y has more valence shell electron than atom X. So if atom Y, because as we move across the period, non-metals will have more valence shell electron, more electron in the outer shell than non-metals, than metals. So Y is having more valence shell electrons, more electrons in the last shell. It means Y is likely to be a non-metal. And if Y is a non-metal, what should be X? X should be metal. Why we say X should be a metal? Because they are forming an ionic compound. An ionic compound can only be formed when metal combined with a non-metal. So if one of the elements we identify as a non-metal, the other one is obviously should be a metal. So which statement is correct? Ions of X are negatively charged. That is wrong. Because when metals are there, metal ions are, when they will form an ion, it will form a positive ion. That is true. But here they mention negatively charged ions, so that is wrong. Atoms of X has more electron shells than atom of Y. Atoms of X has more electron shells than atoms of Y. This will be right. Why this will be right? Because it will have more proton. So if it is having more proton, it means it will have more electrons. And greater the number of electrons, greater the number of electron shells. So that is correct statement. X and Y in the same period of a periodic table. They cannot be in the same period because they mentioned already X is having more protons than Y. So when it's having more proton, it means it will have more electron. So in a periodic table, as we move, like example, this is a periodic table. So here it is proton 1, proton 2, proton 3, 4 proton, 5 proton, 6 protons, 7 protons, 8 proton, and 9 proton. Now what happened? This part is a non-metal. So after non-metal, as I mentioned, X is having more protons. If X is having more proton and it is a metal, so it means it is not in the same period. It should be in the next period. That's why statement C also is not correct, which state that X and Y in the same period. They cannot be in the same period. If they were in the same period, then X should have less proton than Y. Like this statement, if they were in the same period, because on the left hand side we find metal and the right hand side we find non-metal. So if they are in the same period, it should have less protons and it should have more protons. And we move from metal to non-metal. But in the question they mentioned X is having more protons, so it means X is not in the same period. X is in the next period. So they're not in the same period, but here they mentioned they're in the same period. So this statement is also wrong. And X and Y in the same group, they cannot be in the same group because one is a metal Another one is a non-metal. That's why this statement is also wrong. So B is the right answer, that because X is having more protons, so it will have greater number of electrons as well and more electron shells as well. In question 10, the element in group 1 of a periodic table show a trend both in the reactivity and the melting point. Rubidium is in group 1. Which statement about rubidium is correct? So when we check the position, like we have lithium, sodium, potassium, rubidium. As we go down the group, the reactivity increases. They become more reactive. And as we go down the group, the melting point decreases. So it has a higher melting point than potassium. When we compare rubidium with potassium, melting point decreases. So it should be lower, not higher. So A is not correct. It reacts with water to form acidic solution. That is wrong. Alkali metals, any alkali metal is there. Like example, if rubidium is mixed with water, it will form rubidium hydroxide. They are known as alkali metals plus hydrogen gas. So it forms an alkaline solution, not acidic solution. It reacts with water to produce oxygen. That is wrong. It reacts with water. All these alkali metals react with water to give off hydrogen gas, not oxygen. And it is more reactive than potassium. That is true, because as we go down the group, the reactivity increases. So rubidium is more reactive than potassium. So D is the right answer for this. Which is not a property of alkali metals. They are soft, can be cut by a knife. That is true. They corrode rapidly when exposed to oxygen in air, like they react very fast when they are exposed to oxygen. That is true. They produce acidic solution. Just now I explained, whenever alkali metals are mixed with water, that's why we call them as alkali, as they form an alkaline solution. So this is not the correct statement. And they react rapidly with water to give off hydrogen. That is also true. So element which having a high melting point, high density, and form a colored compound. So all these are refers to the properties of the transition element. So where we find a transition element, it is between group 2 and group 3. So this region we can find transition element. That's why C is the right answer. An element does not conduct electricity. So means this gives an idea it should be a non-metal. So A and B are metals. A and B both are metals, so it cannot be an answer. But it doesn't exist. But it does exist as a diatomic molecule. So it cannot be D. Why it cannot be D? Because element in group 8 exists as a monoatomic element. Helium, neon, argon, xenon. So they all are one atoms. Diatomic molecule group 7 such as fluorine, F2, chlorine, Cl2, bromine, Br2, iodine, I2. So C is the right answer. Solution of halogen with sodium halide, which mixture darken basically because of a reaction occur. Bromine, always remember, the more reactive halogen displaces the less reactive halogen from its compound. So fluorine is more reactive and iodine is less reactive. So bromine with chlorine, bromine is down, so it cannot displace. Bromine with fluorine, bromine is down, it cannot displace. Chlorine with fluorine, chlorine is down, so it cannot displace. Chlorine with iodine, so chlorine with iodine, chlorine is more reactive, so yes, there will be a reaction, then it will displace, and as a result, it will produce NaCl plus iodine. So A, B, and C, the reaction will not occur because the halogen which we are using is less reactive than the halogen which is present in a compound. So always the more reactive halogen displaces the less reactive halogen from its compound. So D is the right answer. And the diagram shows a light bulb. Why we use argon instead of air? Because what happened? Argon is unreactive. It does not react. So if argon does not react, so this filament will last for a longer period of a time, because this filament does not react with argon. If there was air, air contain active components such as oxygen, which will react with the tungsten and reduce the strength of a tungsten. That's why we don't use air, we use argon. So what is the purpose of the argon instead of air? Argon is a good conductor of electricity. That's wrong. Argon is more reactive than air. Argon is less reactive than air. That's also wrong. The filament goes brightly. It does not affect the intensity of the light. The filament will last for a longer period of a time because argon is unreactive. So filament does not react with argon and it will last for a longer period of a time. So D is the right answer. Then question 16, elements of a group 7 are known as halogen. Some halogen react with aqueous solution. We have to take, always remember the more reactive halogen, like fluorine is there, chlorine, bromine, and iodine. The more reactive halogen displaces the less reactive halogen from its compound. So if we mix chlorine with iodine, potassium iodide, will it react? Yes, because chlorine is more reactive than iodine, so it can displace iodine from its compound. If we add bromine to chlorine, potassium chloride, there will be no reaction because bromine is less reactive. If we add bromine to potassium iodide, bromine is more reactive above than iodine, so yes, it will react. And if we add iodine to potassium chloride, there will be no reaction because iodine is the least reactive in these halogen. And same thing, iodine with potassium bromide, there will be no reaction occur. Then write equation between chlorine and aqueous potassium bromide. So chlorine is Cl2 and potassium bromide is KBr. When it reacts, because chlorine is more reactive, so it will form potassium chloride. The formula of potassium chloride, potassium is group 1, chlorine is group 7 minus 1. So potassium chloride will be KCl plus produce bromine, because bromine is a non-metal, so it is existing as a molecule, so it should be Br2. Then we'll balance the equation. We put 2 for potassium and bromine and 2 for potassium and chloride, so it will be balanced. So this is the equation for a reaction between chlorine and potassium bromide. Then acetylene is the bottom of the periodic table for group 7. We have to predict the physical state. So we have fluorine, chlorine, bromine, and iodine. So and then we have acetylene. So fluorine is gas, bromine is liquid, iodine is solid, and acetylene is also solid. So what is the state, the physical state? So it will be solid. And write a chemical reaction for sodium and acetylene reaction. Sodium is a metal, so Na. Acetylene symbol is At, and because it's a non-metal, so how non-metal exists as a molecule. As a result, it will produce sodium acetate. So what is the formula for sodium acetate? Sodium is group 1, so +1, and acetylene is group 7, so -1. So formula for sodium acetate is NaAt. So it will produce NaAt. First we write a product and then we balance. 1 mark is for writing a correct, like sodium is a metal, so metal exists as an atom. Acetylene is a non-metal, non-metal exists as a molecule. Then we form a compound. So to write a formula for compound, we have to use a valency. And then we have to balance 2 acetylene, so we put 2 acetylene is balanced. Now 2 sodium, so we put 2 sodium is also balanced. So this equation is balanced for sodium and acetylene. And in question 18, predict how many electrons are there in outer shell of rubidium. Rubidium is group 1. So if element belongs to group 1, group number represents the number of electron in the last shell. So it will have 1 electron in the last shell. Predict one physical property of a rubidium that is same as the transition element. So what is the characteristic of the transition element? They can conduct electricity. So this is a common property for all the metals and the physical property. So it is a good conductor of electricity. All the metals have free electron. Two physical properties which are different from the transition element. They are usually soft and they have low melting point. Then suggest rubidium is added to cold water. When alkali metals are added to cold water, what will happen? Because alkali metal react with water, it will make a solution alkaline and a hydrogen gas is given off. So when rubidium is mixed with water, alkali metal mixed with water, it will form alkaline solution, become alkaline or hydroxide plus hydrogen gas is there. So what are the observations? Whenever gas is given off, you will always write bubbles. And this reaction is exothermic. So exothermic reaction for alkali metals with water, so temperature will increase or the beaker will become or water will become warm. What would be the color of a methyl orange? So methyl orange is added to this. So alkali, what is the color of a methyl orange in alkaline solution? So you can mention it is orange or yellow. Write a chemical equation for reaction between rubidium and water. This I already mentioned here, that when rubidium mixed with water H2O, it will become rubidium hydroxide plus hydrogen. Then we have to balance the equation. So hydrogen 3 are there, so we will put 2. 4 hydrogen, so we put 2. Hydrogen is also balanced. So this equation is balanced in terms of rubidium, hydrogen, and oxygen. Then these are the elements: cesium, lithium, potassium, rubidium, sodium. As we go down the group, the reactivity increases. For alkali metals, group 1, they become more reactive as we go down the group. So lithium is there, sodium is there, potassium, rubidium is there, and cesium. So which is the most reactive? As we go down, the reactivity increases. So cesium is the most reactive and the least reactive is lithium. Now we complete the order. After that, there will be rubidium, then potassium, and then sodium. So most reactive is cesium in this group and the least reactive is lithium. As we go down, the reactivity increases for alkali metals. Then one safety precaution we should take. So because these are highly reactive metals, as these are highly reactive metals, when we are adding them to water, splashing might occur. So we should use goggles. Or use specs. Then the last one, phosphate is having a valency of PO4 with a charge 3-. Rubidium phosphate. So rubidium is group 1. So it is +1 and phosphate is -3 or 3-. So to write a formula of rubidium phosphate, we cross multiply the valency. So this 3 is written here will come with rubidium and 1 is written here will come with phosphate. So the formula for rubidium phosphate, Rb3PO4. So this was about the periodic table.